The Empirical Energy Podcast blows open the silent revolution, rewriting the rules of global energy markets. Measured, verified energy is no longer an alternative. It's becoming the gold standard. We dive deep with the producers, traders, consultants, and renegades driving this seismic shift. Step inside the raw mechanics of how verification and blockchain-fueled trading are dismantling the old systems and creating a future where alternative energy doesn't just compete, it takes over. This is the movement of reshaping energy as we know it, bold, unstoppable, and just getting started. Here is your host, Mark Smith.
Hey everybody, this is Mark Smith, your host of the Empirical Energy Podcast, and I'm here today with Jana Brodersen. Welcome, Jana.
Hi.
So, Jana, tell us about your role at Clean Connect, but then also your background in this whole oil and gas biz.
I've been in the oil and gas business for over 20 years. I've been mostly in the process design or engineering design side of things. And so it involves using a simulation or modeling whatever we're planning to design in a simulator. Usually it's, in my experience, it's been ISCC or BRD's ProMax. And the bulk of my experience has been mostly in upstream oil and gas. I have 4 years experience in LNG design. But the heart of what process engineers do is we model the facility or the facility that we're planning on designing and creating spec sheets and heat and material balances and creating equipment spec sheets that end up being used by mechanical engineers and the whole engineering team to build the facility. So it starts at mass and energy balance of what you're designing, of the fluids that you're trying to process and design, and facility that you're trying to design that would be able to meet the specs that is required by the client. So but in the last, I guess, 5 years, I've gotten more and more involved in the emissions side because I am a licensed professional engineer, and there's been a lot of activity that's been going on with the EPA and that are fining, or the EPA suing the oil and gas clients or people within the Permian. I live now in the Permian and work in the Permian. And so in the last 5 years, I've been doing engineering assessments. So that's when the EPA has flagged to an operator that you have abnormal emissions and you need to have an engineering assessment done to prove, that you've done the corrections that is needed to prevent emissions from occurring in the future.
So one of the things that we've been on a journey to do is what we now call the MMRVT. Okay, so monitor, measure, report, verify, and trade. And we've had other episodes. I encourage everybody to listen to the episode with Shane Foster from Gunvor talking about the trading side. But on the measurement side, one of the things that you helped us figure out was this whole concept of mass balance, being able to take the different meters that are coming in from a client, from their site that's measuring various things, run it through ProMax and this mass balance. So what is mass balance and why is that important? Because what's interesting is that ISCC, which we can get into, it requires ISO 14067 with mass balance. In fact, everything about ISCC is about mass balance. In fact, I'll show some other slides here that kind of illustrate that point, especially when you're talking about feedstock blending. Okay, so in this case, taking empirical natural gas, which we're working with Pure West, and you're actually measuring their gas and their emissions, and then combining that, let's say, with empirical RNG, renewable natural gas, blending it, and then being able to do something like a book and claim or physical delivery under these ISCC rules. And so, yeah, the mass balance is super key. In fact, ISCC allows for this feedstock blending under this ISCC plus. And so we've gone through all of these certifications. In fact, I definitely want you to talk about going through the ISO 14067 certification process because that was a lot of back and forth with the auditor. But on February 17th, we got this beautiful letter from Spirit Environmental saying, hey, we attest that we got this 14067 with mass balance certification. And I know that was a heck of a lot of work on your part, Jana, to help make all of that happen. So anyway, talk about mass balance. I do have this diagram if it's helpful to explain a little bit what mass balance is.
In a very simple perspective, it's a check balance. So if you're going through a checking account and you're wanting to see how much money is coming in versus what's leaving, that's what you would want to do in terms of making sure that you're able to track everything that's coming in and what's being spent. And so it's the same concept within process engineering. That's what our career is solely based on, is just when you do a simulation, you want to make sure that whatever mass is coming into your system is equal to, it's all traceable. So it's equal to whatever is leaving or being or even transformation or like a chemistry. But on a mole basis, it's all about what is a check procedure on what's coming in versus what's leaving. It's Mark, when you asked, how do we get to where we're at today? And we started off with the vision of Luminary and trying to integrate the IoT data with Luminary. And I think maybe you'll probably talk more about that later, but we could.
Yeah, I'll show a slide on that in a little
We'll
bit.
get
Yeah.
there. And so the concept was, can we create a digital twin? And when you integrate your mass meters or your flow meters into data integration, which is what we use ProMax, into your simulation, you now have a real time or a digital twin of your facility, of the fluid flowing through your facility. And that's where it initially started with, was like, oh, ProMax, which is now has the new features of having data integration. I think ISCC and other simulators have that capability now, where you can connect your variables in with the database and then have a digital twin of the facility. And so that's how it started. And then we went into getting into these certifications, and what the certifications are solely based on is having a mass balance. And so that was the nice luxury that we had on top of that, was, oh, great, now we already have this integrated system, which is ProMax integrated with data, the real-time data, and this is an added benefit. So now we could show what the mass balance is through any piece of equipment at any time. The other thing is too, is, you have mass balance on the overall facility, but you can have mass balance on individual components within the facility too. That's how we got to that point.
Yeah, and you mentioned Luminary, and for those, so that is our digital twin system. And when we originally created it, we did it so that we could virtually place a tower, and not, because placing a tower physically and then moving it later is problematic. So actually be able to virtually place a tower, virtually place a camera, and see what the camera will see before you get there is advantageous. But in addition, built some level of process mapping in here to where you saw in there where we could put the flow between objects. So you could see gas, water, oil moving between objects and be able to manage that. The idea of having a digital twin now is the ability to take that raw telemetry data, map it to this digital twin, and begin to categorize that data so you know what it is. And then you could take it from there over to ProMax. And I know this is the process that, as I recall anyway, just watching you from afar, mapping that IoT data to ProMax originally took how long would you say for a site?
I think that some of it is just a challenge because of working with new disciplines.
Yeah.
So some of that was that, and trying to, how do we align and plan that out initially? So yeah, I think it probably took 6 months for one facility to get through and get it all working correctly. Yeah.
So I know now we're trying to get that down. I don't know to more like 6 hours or something, and
Oh, yeah.
yeah, because
Yeah. We even have future plans where not only that, but just remove me from the picture and use Luminary to generate a simulation. And that's probably a goal to have that complete within a year to 2 years. So then I'm not even building a simulation, but right now what Luminary does is it does the automatic mapping from the source data to it creates an XML which tells ProMax that this variable matches this variable. And so we have a standard philosophy, a convention of how we number our equipment and how we name all the variables across all of our different platforms. So it's easily mapped. And then I import that XML into the ProMax simulation and it automatically maps it all.
which is amazing because I think of our clients, right? So let's say our clients acquire a company. We have some clients that acquired 5 companies. And if you think there's an industry standard way of describing meter data, that's not the case, right? They may have 5 different standards from these 5 companies that they've inherited. Now they're rolling them all up. And so being able to do that at scale quickly and then categorize all of that data is a big deal. In fact, this is where most of these projects fail, right? They'll spend a year and a half trying to map one site. And so to be able to tell clients, hey, we can map 100 sites in a month is a big deal. It allows this thing to happen at scale. Okay, what else happens though? Because some of the things you had to pioneer was this idea of a data fidelity score. So what is that? And how does like meter data and the accuracy of the meter data or how recently it was calibrated and things like that impact that score?
Yeah. So the thing is about our team is having experienced professionals working closely with the SMEs of the operator. So I think it's important to be able to, even from the point of bringing in data, it's working closely with the operator and understanding how they're building their systems, like with their SCADA and all that. That's important. But it's also too about when we get down to the mass balance part of it, if they don't have a meter, historically, many of the operators that I know in the Permian do not have fuel gas meters. So we have discussions with the SMEs on what's another way of quantifying that. And so we go through those one by one, whether it be from data, like how do we quickly access their data and getting it in a format that is easily digested on our part in helping them with that, or all the way to the point of looking at the mass balance and the different variables that are involved within the ProMax simulation of the facility. And if there is a missing critical device, then like in terms of fuel gas, then what sorts of substitutions or how do we estimate that? And it's working with each client and their SMEs on setting that up and figuring out, do we use ProMax? Do we write a different calculation? Do you want to put in a temporary meter? Do you want to go out and do some other testing? And so it's walking through one by one on, and then once we have that whole plan in place, then it's just implementing it and it's all automated from there.
And I think that's one of the things going back to talking about the overall platform, the fact that you figure out mass balance and look at the meters and all that in and of itself. But we also have this camera sitting out there in many cases where it's another, if you will, meter that's out there looking at something. And so, if you have a tank at overpressure, the camera detects it, it starts to try its own measurement, but then to be able to reconcile that against a mass balance loss or against other calculations is a unique combo of the measure and manage. And I'll pull that out just to show that. Again, monitoring here and then measuring here. We can use both of these things to help with the calculations. I think that may have been the knock on mass balance in the past where they said, wait a second, you're detecting this mass balance loss, but you don't know where it is, right? Now, that may not be entirely true because you said you've got this overall mass balance, but you have mini mass balances within that overall closed system. Is that true?
Yes, yes. And so what's good too about having that integrated with Luminary is you can see from the camera the specific device that's emitting. So then that would allow further investigation on how you want to quantify that. You want to use the machine learning model that does the quantification. You want to look at sending an operator out there that uses a calibrated bag to try to capture that emitting device if it was emitting continuously. Things like that, that offers a more flexibility for the operator to get down to the specifics about, what device is being emitted, and even just like being able to build a program to track, is there a continuous problem with a specific device that keeps on emitting, to start studying that even more in depth.
Yeah, and I think that is the point here where as Luminary continues to, our digital twin continues to evolve, it's the camera, instead of just seeing the object, a video object, it actually knows what it's looking at. It's more like seeing an augmented reality. So it's saying, hey, I know the field of view I'm looking at, and I know that there's a bunch of equipment there, but because I'm now tied or integrated with this digital twin, I can know more specifically that. And I know, if anything, the goal of this show, Empirical Energy Podcast, is to bring together sort of energy, AI, and actually blockchain, right? The crypto type tech. And this for sure does a number of things. Obviously, the trading part, we got the blockchain and things like that, but even capturing all of the output from your measurement goes into those EACs, or environmental attribute certificates, which are on the blockchain. But now we're even using AI to help us identify objects, marry it with the digital twin and things like that.
Once you get it really integrated with your IoT, and you can look at like cause and effect, charts, and then you could see at, because in process safety, there is this layer of protection analysis, and that goes through, like, when an event is about to happen, there's certain things that has to happen. We have a high pressure here, we shut down this, we close this valve, we do things like that. And then if it ends up emitting, it's because something has, like a PSV that has emitted, it's because multiple layers have failed. And I think that story we'll probably be talking more about in the future, in that it reduces risk too, because now you have another layer of protection. You have a camera that's now on site, that is your eyes for the facility, that you can actually see that something is happening that shouldn't be happening, which is emissions.
So I know you're in the trenches all figuring this out along with the rest of the team, like Ryan and stuff, but what are you, as you see the future of where this is going? You mentioned a couple of years, some stuff will happen. Like, where do you see this stuff going?
I think ultimately, like specifically for onshore facilities in the Permian, I think that there's great challenges in how do you manage manpower and within, because you've got so many facilities, small facilities that are everywhere onshore. And so how do you prioritize, your operations? But it's also, we just have so much data. And so what do we do with this data? And what can we do with the data too? And I think that the camera is an added layer of benefit, because then you can also tie that to your IoT data, and it can help you. We're building programs on data integrity, what I would classify as a critical emission device. That would be a device that be setting up rules that would flag, hey, your reboiler temperatures stopped coming in, or it went down, and that's critical, or a specific meter that's a critical meter that is no longer in the right measurement range. That's critical. But I also believe, I think the crux of this all, the most important thing, is how do we help operators optimize the use of the people that are in the field in managing this emissions challenge that we have in the industry.
Very good. Jana, thank you so much for being here. and lending your expertise to helping explain mass balance and the whole measure side of what we do in the MMRVT. Thanks a bunch.
Thank you.
The Empirical Energy Podcast requires more than a conversation. It takes action, research, and collective wisdom. If today's episode resonated with you, we'd love to hear your insights. Join the conversation and help us shape the future together. We'll be back with more stories, strategies, and real-world solutions that are making a difference for everyone. In the meantime, be sure to subscribe, rate, write a review, and share it with someone you think would benefit from it too. Thanks for listening, and we'll see you on the next episode.